In this video, I'll show you how to solve the ALEKS problem called predicting the formula of ionic compounds with common polyatomic ions. This problem is going to give you the formulas for 2 cations and 2 anions, and it wants you to come up with 4 ionic compounds that could be combined with these different ions. Theoretically, any cation can be combined with any anion, so what we want to do is just write all possible combinations for these ions. I'm going to begin by writing the lead ion, Pb4+. We want to consider the possibility that the lead ion reacts or combines with the IO3 minus polyatomic ion. We'll see what we get from that. And also we want to write the formula of the ionic compound that we would get by combining the lead 4+ ion with phosphate PO4 3-. That's going to be 2 of the 4 ionic compounds. The other 2 ionic compounds are going to come from the Fe3+ cation, combining with each one of those anions. I do at this point want to remind you that conventionally when we're writing the formulas of ionic compounds, we always write the cation first and the anion second, the positively charged ion first and the negatively charged ion second. When we are combining ions, we want to do so in a way that the positive charges balance out the negative charges. So if we have a 4+ ion like we do in this case, we're going to need a total of -4 coming from all of our anions. That could be sometimes a little bit tricky to predict exactly how many of each ion we need, so we do have a pretty handy guideline that we can follow to help us predict how many of each ion is necessary for the formulas. The charge of one ion, for example the 4 on the lead, is the quantity that we need of the other ion. The charge, in this case of the iodate, the 1- charge, that's the quantity that we need of the lead. So I'm going to use that guide to help me write these formulas out. The charge on the IO3 is a 1, which means I only need 1 of the lead ion. And as you know, in formulas, we don't write 1, the subscript 1. For the IO3- ion, the quantity that we need is 4 because that's the charge on the lead. The way that we're going to indicate that we need 4 of those is that we're going to write that whole entire formula in parentheses, and then we're going to put a subscript 4 on the outside of the parentheses, and that's how we would indicate we need 4 of everything inside the parentheses. Some common mistakes that students make when they're writing the ionic compounds containing polyatomic ions is that they multiply that subscript, in this case the 4, they multiply it into the parentheses and they come up with something like this. And that is not how we would write this. We want to keep that polyatomic ion unit intact inside parentheses. Another really common mistake that students make is leaving the charges in the formula, and that also is not okay, so don't do that. Let's take a look at the next possible combination. Remember the charge of the PO4 3- ion, that's the quantity of lead that we need. So that's going to be Pb3. And the charge on the lead, that's the amount of phosphate that we need. Put that in parentheses, PO4. And then the 4 goes on the outside of that. Let's take a look at our next one. The quantity of the the charge of the IO3 is the quantity of the iron that we need. That's just 1. And the charge on the iron is the quantity of the IO3. So that's a 3. And then last but not least, the charge on the phosphate is the quantity of the iron, Fe3. And the charge on the iron is the quantity of the phosphate, PO4 3. Do keep in mind when we're writing these ionic compounds, it is always necessary for us to evaluate the subscripts, in this case 1 and 4, 3 and 4, 1 and 3, 3 and 3, and see if we can simplify those subscripts into smaller numbers while maintaining that ratio. So up here we have a 1:4 ratio, and we cannot simplify that into any smaller numbers. Here we have a 3:4 ratio, that also cannot be simplified. Here we have a 1:3 ratio, again can't be simplified. Here we have a 3:3 ratio, which we can simplify to a 1:1 ratio. So when we're simplifying these ratios, we're trying to maintain the ratio, the number, the relative number of each ion, but we want to bring these numbers down to the smallest possible numbers that we can use. So this last compound, this one needs to be simplified to FePO4, like that, which we would also, if there's no subscript outside the polyatomic ion, if we don't have a subscript out here like we do in these other cases, then it is not necessary for us to have the parentheses anymore. The parentheses are just there for that external subscript, and if there is no external subscript, then the parentheses do not belong.